In today's video, I would like to introduce a very nice problem of Yugoslav Mathematical Olympiad of 1996, question number 3. Here is the following setup. Find all solutions for this pair x, y, z as non-negative integers. We have this following statement: square root of x plus square root of y plus square root of z equals square root of 1996. Okay? The square root of this number is representing the Math Olympiad of that year, okay? 1996. This problem looks like hard in the beginning. Once you find the trick, everything else will be easier to solve, okay? Go ahead, pause this video if you would like to give the try to this problem. When you come back to see the full solution. Okay, let's get into the solution. So the first thing that I'm going to notice here, if you try to raise the left hand side of this equation as a quinary square, it will be hard to simplify this one, okay? So I'm going to use a trick. I'm going to move this one to the right hand side of this equation and solve and apply the exponent for the both sides, okay? So let's do that. I will have square root of x plus square root of y plus square root of z equals square root of 1996, okay? As I said, I'm going to move over this square root of z to the right hand side of this equation. I will have square root of x plus square root of y equals square root of 1996 minus square root of z, minus square root of z, okay? So I'm going to raise number 2 as a power on both sides and simplify this expression. This one is giving us x plus y plus 2 times square root of this product x and y equals the right hand side of this equation equals 1996 by taking this square root off of this one minus 2 times 1996z. All of those terms are inside of this square root plus the last term, which is z. I'm going to leave this x plus y as they are and bring this 1996 to the left hand side of this equation next to these terms. I'm going to leave this x plus y as they are and bring 1996 and z to the left hand side of this equation next to these terms. Then I move over this term to the right hand side of this equation, okay? And I will make a nice combination. So I will have x plus y minus z minus 1996 equals this term. By moving this one over to the right hand side of this equation, I will have minus 2 as a common factor for both terms. Minus 2 is multiplied by square root of x y as a product plus this term square root of 1996z. If you take a look carefully at the left hand side of this equation, so the left hand side of this equation, this is integer, okay? That means the right hand side of this equation must be integer as well. Since the right hand side of this equation is an integer, that means this term is an integer as well as this one, okay? Both of them are whole number. So I'm going to work on this one now. 1996 equals 400 is multiplied by 499. Since this one is an integer, we have 1996z. This one is an integer. Since this one is an integer, we know 1996 equals 4 is multiplied by 499 z. I'm going to take this out of square root. I will get 499z, which equals, since this one is an integer, that means z equals 499 is multiplied by c square, where is this c is a sum natural numbers, okay? Because when you multiply 499 by this term, is automatically come out of the square root, it become an integer, okay? For the c is an integer because c, it could be positive, it could be negative, because we have square root here. So this argument follows similarly for x and y, because we have a nice symmetry here. Whatever happened for x, it will happen for y and z as well. That means y equals 499 is multiplied by b squared, where is b the sum natural numbers, and x equals 499 is multiplied by e squared, where is a sum is the sum natural numbers. Okay, so what I'm going to do now, I'm going to take these found facts and plug it into this equation. Okay, so we'll get square root of x, which is square root of 499 is multiplied by e squared, plus square root of 499 is multiplied by b squared, plus square root of 499 is multiplied by c squared. The whole thing equals to square root of 1996, which equals to is multiplied by square root of 499. Because we already mentioned 1996 equals to 4 is multiplied by 499. Now we will have a nice cancellation here. This 499 will be cancelled out with this one and this one and this one, because I'm taking square root of 499, because I'm taking square root of 499 as a common factor, and will be cancelled out with the right term. Okay, so and then by the way, as you take in the square root of out of these terms, this one will become a, this one will become b, this one will become c. So that's mean I will have a plus b plus c equals number 2. Okay, here is a nice expression here. So I'm going to find ABC. I'm going to make the chart here. I will have a, b, c. When is a is taking number 0, that's mean b is taking number 1, c is taking number 1. When a is taking number 1, that's mean b is taking number 1, the c is taking 0. When you have a is taking number 2, that's mean b is taking number 0, the other one 0. Okay, when a equal to 0 to 2 and c is taking 0, and also when a is taking 0 and the b is taking 0 and number c is taking 2. Okay, without loss of generality, if x, y, z is a solution, and also y, x, z is a solution, and also z and x, y is a solution. Okay, because I have a symmetry here. For the first case, if a equal to 0, that's mean x equal to 0. If b equal to 1, that's mean I have 499. If z equal to 1, that's mean I have 499. The second possibility, I'm going to work on this line now. For a equal to 1, that's mean I will have 499, because 1 is multiplied. I'm replacing a with 1 here. Okay, for b equal to 1, that's mean I will have 499 as well. The last one I have 0. For the third line, if a equal to 2, that's mean I will have 1996. Okay, because I'm replacing number 2 here. I get 4. 4 is multiplied by 4 and is given as 1996. B will be 0. The c will be 0. For the fourth line, if a equal to 0, that's mean x equal to 0. If b equal to 2, that's mean is taking 1996. If c equal to 0, is giving us 0 here. For the fifth line, both of them x and y are 0, because the first one is 0, the second one is 0. The last one is 1996. Okay, I miss another solution. 499, 0, 499. Okay, I have found 6 solutions here. I have done with this problem. If you are interested watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.